Okay, so we talked about quadratic equations being those equations of the form ax squared plus bx plus c. In this case, when we solve, we set it equal to 0 because we're solving for the roots. Linear equations make lines, quadratic equations make parabolas. And then we talked about quintic and quartic equations as well, but we're going to focus on quadratic equations as parabolas today. So, solving quadratic equations by graphing, write the equation in standard form. Some of you still don't know what standard form is. Okay, standard form is you have the highest exponent with that coefficient coming first. So if you don't have that, it's not written in standard form. Followed by the next highest, and so on and so forth, and then you have that in standard form. Some of you, on the last chapter test, it said find the sum or difference, and we're multiplying. We're FOILing. We're using the distributive property. What's sum or difference? Add or subtract. And some of you are multiplying, and I don't know why. Okay? When it says find the product, and they're next to each other, that's when you do the FOIL thing. It says graph the related function. We're not actually going to look, I'm not going to require you to graph that because we don't know how to graph it quite yet. Find the x-intercepts, if any. Those x-intercepts are your solutions. We should already know how to do that by setting the equation equal to 0. The solutions or roots are the x-intercepts of the graph, so that's nothing new. So we're going to take a look, just sort of reinforcing the concept because it is so important. So it says solve x squared plus 2x equals 3 by graphing. Again, what does it mean when it says to solve by graphing? What are we doing? Well, we don't know how to graph it. Yes? Find the x-intercepts or the roots. So that's what we're going to do. So what's the first step in finding those x-intercepts or roots? What do I have to do with that equation? Subtract 3, set it equal to 0, so that's what I'm going to do right now. I'm going to subtract 3 on either side. And then when I have everything on one side, I end up with, of course, x squared plus 2x minus 3 equals 0, and I factor that. How do I factor that? You don't have to do the box method or bottoms up with the whole AC thing. Why? Is there a coefficient other than 1 here? No. So you just have to set up the x. What goes on top? Negative 3. What goes on the bottom? 2. What are your p and q? 3 and negative 1. So when I factor that, I get x plus 3, x minus 1 equals 0. I set each factor equal to 0. On that test, I had an equation that was like that. It was a graph. I said find the roots, and some of you didn't know what to do. You just looked at it and told me the answer. Okay? All I was asking you to do was take that equation I was giving you, that I gave you, and factor it. Fill out your GCF. There was a GCF, and then you had to set each factor equal to 0. So in this case, you're doing the same thing. We want to know on that graph where it's crossing the x-axis. So x plus 3 equals 0. X minus 1 equals 0. So what are my roots? Negative 3 and 1. And that's what I was looking for on the exam yesterday, or when you took it on Friday. If you didn't show that word, you missed the point. And then this is what that graph looks like. If we knew how to graph it, if we had the tools to do that, then we could verify. But we just found those points. Those were the solutions that we're looking for. Okay. Let's go to the next. Okay, try those. Okay, if you're watching the video here, let me unveil the answers. Are there any that you need to see? them all? Good. Now, notice you are seeing a lot more like 2 and 3, where you have to make sure that you have everything on one side set equal to 0. So hopefully, now that you've seen it again, you won't make the mistake that you might have made on the exam. Yes? What? I can do one of them. Yeah. What do you need to see? No, not the same thing. So, let's look at number 1. Well, it was on the top box, or the top. Negative 2, negative 1. So it multiplies to be negative 2 and adds to negative 2 and positive 1. So your factors are x minus 2, x plus 1. When you set x minus 2 equal to 0.
I knew I did something wrong.
Yeah. That's probably what you did too, right? You just mixed up the signs. So that equals where you add to instead. Anything else? All right. 2 other types that you will see, most likely. Same process, but we may get repeated roots. We may get no roots, meaning that it's essentially unfactorable. Or at least imaginary roots, which you haven't learned about yet. So for that first one, what do we do first? Add 16 to both sides, and I get x squared minus 8x plus 16 equals 0. There's no GCF because there's a 1 there. Because there's a 1, I can just do the x. 16 and negative 8. So what multiplies to be positive 16 and adds to be negative 8? Negative 4. And negative 4. Yeah. Okay. So we essentially have x minus 4 squared equals 0. Well, I'm going to get the same root what? Yeah. So if I do that, I just get x equals what? 4. And that's a repeated root. Well, what does that look like graphically? It looks like this. Just that single point. Right there. Does that make sense? Okay. Now, the other situation that we'll find is sometimes we'll be dealing with something that's just not factorable, and that's okay. So on this next one, I can subtract, I can add x squared to the other side. I'll end up with 0 equals x squared plus 2x plus 4. Remember your symmetric property says you can switch that to x squared plus 2x plus 4 equals 0. Same thing. So when I make my x, what multiplies to be 4 and adds to be 2? Nothing, right? Because before I just have 4 and 1, and I have 2 and 2. So this is unfactorable. What does that mean about the roots? That means, not have that up on there. That means that you'll have a situation like that, where it doesn't cross that x-axis line. Do you have any questions about the types of roots that you'll encounter? What it means to solve by graph. Now, if you actually knew how to graph, which you will learn again, you can check, you can verify with that graph. Okay. think we have one more example, and then we'll be done, maybe. Okay. I said this prior to the recording, I'll say it again. Number of solutions of a quadratic equation, 2, 1, and none. Really has to do with what you factor out and what that looks like. So for 2, you have 2 roots. 1, you have a repeated root, and none, you have an unfactorable equation. You can actually find those imaginary roots, but you won't be able to do that until algebra 2 when you work with imaginary numbers. But we're not going to work with imaginary numbers right now. Okay, this isn't a quadratic equation. This is a cubic graph. It crosses the x-axis 3 times. It has 3 roots. The graph of the following equation is shown. Find the zeros. Zeros and roots are the same thing. So 3 different ways we can express the same bit of information that you need to be aware of. If someone asks for x-intercepts, zeros, or roots, they're asking for the same thing. X-intercept, zeros, and roots. More often, you'll start hearing the word zeros rather than roots, but they do mean the same thing, essentially. They may vary on very subtle lines, but they mean the same thing. Roots, zeros, x-intercepts. Okay. So, to find zeros, what do you think we have to do? So, just like we did, set f of x equal to 0, which of course, again, makes sense because here, my y's are 0. That's why we do that. 0 equals x minus 3, x squared minus x minus 2. On the test, there was an equation that I had you factor, and some of you pulled out the 6, and you left me with x squared plus something x plus 2, and you didn't continue to factor it. If you left it like this, you lost points because you didn't factor completely. You have to factor completely. What that means, again, is if you see something like this, you need to make sure it's completely factored all the way through. So, that first one, there's nothing I can do about that, x minus 3, but maybe I can factor out the next part of it. Let me see if I can. So I have negative 2 on top, and I have negative 1 on the bottom. What multiplies to be negative 2 and adds to be negative 1? 3. What multiplies to be negative 2 and adds to be negative 1?
2 and negative 2.
Thank you. So, 0 equals x minus 3, x minus 2, x plus 3. So what are the roots?
3, 2,
Yeah, 3, 2, and negative 1. So again, point to learn. If on the test you see something like this and you stop, that means you may have gotten it wrong because you need to go further. Probably. Once again, practice. Which in this case, I could go further. So go as far as you can. Alright. That's it. Do you have any questions about this lesson? I'm going to finish grading the tests for 6th period, and then I'll start calculating the average. I want to give you your test and go over it one day this week, so probably the end of the week. Probably. Thursday or Friday, I'm not sure. And let me get the new table of contents on here. First item. Again, a reminder, if you get a D or an F on the Chapter 7 test, before corrections, everything, I'm going to give you a slip that you must sign in order to get the points for the curve. So if I end up curving it, for example, by 3 points, let's say, to get those points, you have to have a signature from your parent or guardian that says, I'm aware that my son or daughter failed the factoring test and that factoring is an essential part of the curriculum, so here's what I'm going to do about that, okay? So you will get a slip if you got a D or an F on this test. If you got an A, B, or C, you don't have to worry.